Hello everyone. Welcome to today's lesson. Have you ever wondered how we measure rotations or turns in real life? Think about turning the steering wheel of a car or the hands of a clock. That rotation, that movement from one position to another, is exactly what we call an angle in mathematics. In simple terms, an angle is formed when a ray, also called the initial side, rotates around its starting point, which is called the vertex, to a new position called the terminal side. If the rotation is counterclockwise, we say the angle is positive. But if the rotation goes clockwise, the angle is negative. For instance, think about the rotation of the minute hand of a clock. As the minute hand moves, it forms different angles with the 12 o'clock mark. And that's exactly how we measure angles, by understanding the rotation between the initial and terminal sides. Simple, right? Now that we understand what an angle is, let's talk about how we measure it. There are two main units used to measure angles: degrees and radians. The degree measure is the more familiar unit, where one complete rotation equals 360 degrees. Think of the rotation of a clock, a full circle. One complete revolution is 360 degrees. If we break it down further, 1 degree is divided into 60 minutes and 1 minute into 60 seconds. On the other hand, the radian measure is a bit more mathematical. A radian is the angle subtended by an arc whose length is equal to the radius of the circle. In a circle with a radius of 1 unit, an arc of length 1 unit subtends an angle of 1 radian at the center. To give you a better perspective, 360 degrees is equal to 2 pi radians. This means one complete revolution of an angle is the same in both degrees and radians, just measured differently. Let's dive into how we convert between degrees and radians. There's a simple relationship that connects the two. For example, since 360 degrees is equivalent to 2 pi radians, we can easily convert from one to the other. To convert from degrees to radians, you multiply the degree measure by pi divided by 180. And to convert from radians to degrees, multiply the radian measure by 180 divided by pi. Here's an example. Convert 40 degrees 20 to radians. First, we know that 1 degree equals pi divided by 180. So, 40 degrees 20 is equal to 40 plus 1/3 degrees, which we can then multiply by pi divided by 180 to get the radian measure. This gives us approximately 121 pi divided by 540 radians. Another example, convert 6 radians to degrees. Using the formula, we multiply 6 radians by 180 divided by pi, which gives us 343 degrees 3811. Now, let's talk about a special type of angle called quadrantal angles. These are angles that are multiples of pi divided by 2 or 90 degree. In simpler terms, they are the angles that lie along the axis of the unit circle. The most common quadrantal angles are 0, pi divided by 2, pi, 3 pi divided by 2, and 2 pi. For example, cos of 0 degrees equals 1, sin of 0 degrees equals 0, cos of pi divided by 2 equals 0, sin of pi divided by 2 equals 1, cos of pi equals -1, sin of pi equals 0, cos of 3 pi divided by 2 equals 0, sin of 3 pi divided by 2 equals -1, cos of 2 pi equals 1, sin of 2 pi equals 0. These values are very important when working with trigonometric functions. Quadrantal angles form the foundation of many trigonometric calculations. They help us understand how sine and cosine functions behave at key points on the unit circle. As we move along the unit circle, the signs of trigonometric functions like sine, cosine, and tangent change depending on which quadrant the angle lies in. In the first quadrant, from 2000 to pi divided by 2, both sine and cosine are positive. In the second quadrant, from pi divided by 2 to pi, sine is positive, but cosine is negative. In the third quadrant, from pi to 3 pi divided by 2, both sine and cosine are negative, but tangent is positive. In the fourth quadrant, from 3 pi divided by 2 to 2 pi, sine is negative, cosine is positive, and tangent is negative. This is essential to know because the signs of the trigonometric functions help us solve many types of trigonometric equations. Let's quickly summarize what we've learned today. Angles are created by rotating a ray around its vertex. We measure angles using either degrees or radians, with one full rotation equaling 360 degrees or 2 pi radians. We also explored how to convert between the two units. We also discussed quadrantal angles and their significance, as well as how the signs of trigonometric functions change across the 4 quadrants. I hope now you understand how we measure angles and why it's important in the context of trigonometry. In the next video, we will dive deeper into trigonometric functions and their properties. See you soon.